Greetings everyone and welcome to Writing the Physics Lab Report. Here we are on my homepage, right? And there are of course many attached pages, one of which is called Lab Help. That's the one we're going to talk about today. We're going to talk about some pieces of it because it will help you write up lab reports in here. Exactly like it sounds. So you'll notice two things that are on there right now. One is sample lab reports. We're going to look at the Circle Lab here as a kind of example of a type of lab, and the Circle Lab 2 is also on here. I've written these up over the years, and then we can use them as examples. Down here, data analysis with Logger Pro is what we have, the laminated sheet that's by every computer in the back. And so if you're at home and you wanted to use Logger Pro, this would tell you how. Using Logger Pro with Word will be a separate video. The lab scoring rubric is, as you would expect, a rubric. It's something which will be on the back table when you turn in your lab report. You'll staple it to the front of your lab, and it will be the way that I will grade the lab. It's also a good way to kind of checklist to make sure everything that's supposed to be in the lab report is in the lab report. And what we're starting with today is called Writing the Physics Lab Report. So here is Writing the Physics Lab Report. It's a one-page document. You could print it off if you wanted and keep it in your notes, or you could just look at it when it came time to write the lab. And it's giving you a pretty detailed thing of what should be in each section of the lab. So, lab reports must be word processed. You should put your name, the name of all your group members, and the date you did the lab in the upper right-hand corner of the first page. You should put a title on the top of the first page. And then you should have all of the sections prefaced with the section names: purpose, apparatus, procedure, data, evaluation of data, and conclusion. So if we go and look at my version of the Circle Lab, you can see here's my name because I did the lab by myself. This is the date I did the lab, September 4th, 2003. So roughly 10 years before this video. Here's the title right on the front page, and notice it's a descriptive title, the Circle Lab. Rather than using a title page because that wastes a whole page of paper. And then you notice here, here's my lab. And you can clearly see the different sections: conclusion, evaluation of data, data, procedure, apparatus, purpose. Now there's no real need here to reinvent the wheel. So this is a Word document. So I would suggest that you use this Circle Lab as kind of a template. Delete the words that don't apply to yours and type in the words that do. And if you do that, you ought to get a lab that at least somewhat looks like this and is organized correctly. So there's really no reason to have an unorganized lab since you have these Circle Labs as templates. So what goes in each section? Well, the purpose section is where you put the purpose. That's something that's given to you or that we brainstorm as part of a pre-lab. It's always using graphical and mathematical representations to create the relationship between the variables. Apparatus is two parts. Go back to the document here. It's a list of all laboratory equipment used and a detailed diagram that shows how the equipment is put together, including the variables to be measured, should be shown here. So if we have a ball that's rolling down this incline and then it flies off as a projectile, there's two variables we're measuring. We're measuring how far off the table it flies before it hits the ground, that's x, and we're measuring the height that it's released from, that's delta h. In my Circle Lab, here's the equipment we used. We used a measuring tape and various circular objects. And then here's my diagram. Now, I tend to make my diagrams using Word Draw down here. But if you want to hand draw it, you can, or if you want to get a circle off of the internet and paste it in, something like that. Here you can see a circle, and you can see the two measurements we made: the circumference, which is the distance around the outside, and the diameter, which is the distance across the middle. So, some labs are a little bit easier than others to draw pictures. Now, that's the apparatus section, so two parts to it there. The purpose. As you might expect, the purpose is where you are going, the procedure is where you are going to write out what you did in the lab and how you did the lab. You need to talk about how you controlled the variables, right? And also, especially the independent variable. Basically, you need to find a happy medium here where somebody who wasn't here could read your procedure and figure out how you did the lab. So, not just one sentence. We measured a bunch of circles. Not enough. But also, on the other hand, I don't need to know every button on the calculator you push to make a calculation. You got to find something kind of in between. So going back to my Circle Lab, you can read the procedure. And as you read it, you'll notice it's short, but it does say exactly how we measured the circumference, and then how we measured the diameter, and then what we did afterwards. We repeated it for all the other circular objects. Okay, so that's the procedure. And notice that it's in paragraph form, please. I would prefer that rather than step 1, step 2, step 3. Data section. That's a little different. Data section has a data table, and it's a proper physics data table with the units for the measurements on top and the names of what you're doing on top, the column headings, right? Just like we do in Logger Pro. But in the data section, you only want to put raw data. No data that has any mathematical manipulations or interpretations have to be in here. So no averages or squares or square roots or things you had to plug into other equations. That's going to come in the next section. So in the Circle Lab, that's all we had was raw data. It was data we took right off of the measuring tape. So here's my data table, and notice we have diameters in centimeters, circumference in centimeters. So we have what we're graphing, or what we measured, sorry, and the units. And then we have the data. Nice, organized data table. But again, this is only the raw data. This is going to come up in the very next lab that we're going to do, where you're going to have some data in the data section, the raw stuff we take right off the device, and then the manipulated stuff, the averages, will go in the next section. That's called evaluation of data. Now, in the evaluation of data go several things. As you can tell, a graph goes in there. Or if there's more than one, both graphs would go in there. If you look at the Circle Lab 2, there's 2 graphs in there. Now, if we have any manipulated data, then you need to put that in the evaluation of data section. Now, that may seem a bit strange, okay, but if we go here and if I open up the other lab here, so if we look at the Circle Lab, here's our raw data, Circle Lab 2. Here's our squares, right, are in here. And I'm going to show you in the other video how to get this stuff in there from Logger Pro. Okay? Also, there's a statement of graphical relationship, and it should look pretty much like this one. We graphed the circumference versus the diameter, got a straight line of correlation coefficient 0.9962. See, we took that right off of here. So notice, I didn't just say the line was straight, I proved it. Then, since the relationship is linear and the line contains 0, 0, the circumference is directly proportional to the diameter. So this is a statement of graphical relationship, as it's called on the rubric. So these are all the things that go in the evaluation of data section. Data table for manipulated data, graph or graphs, and a statement of the graphical relationship. Now, the big part of the lab is the conclusion. If you look at the rubric, it's actually 10 of the 25 points is in the conclusion. And that's because the other parts are really just something where you're doing the lab, you're explaining what you did. This is the part where you explain what it all means, all right? This and the evaluation of data section. Okay, so if we go to the writing the physics lab report again, you're going to do a lot of things in the conclusion. You're going to state the relationship between the variables identified in a clear, concise English sentence. You're going to create specific math models and general math models. You're going to state the meaning of the slope and the y-intercept when it's appropriate, when you can. You're going to make sure everything has appropriate units. You're going to describe any new terms, usually things that we talk about in the post-lab. And then you're going to do sources of error. Okay? That might include a percent error calculation. It might not. Some labs have them, some labs don't. And the big thing about a conclusion, like the procedure, it should be in paragraph form, and it needs to flow. By that I mean that I do not want my procedure to be a list of things. Here are my new terms. Here are my equations. Here is my percent error calculation. I want a paragraph that flows, much like when we do the post-lab itself. So, take a look at my conclusion in the Circle Lab. And just read along with me the very first sentence. As stated in the evaluation of data section, the circumference, capital C, the distance around the perimeter of a circle, is directly proportional to the diameter, capital D, the distance across a circle through its center. Circumference is proportional to the diameter. And I'll, by the way, tell you how to do these fancy things in the other video. Notice that in that one sentence, I did several things. I restated what we found here in the evaluation of data section, so in clear, concise English sentence. I introduced a couple of new terms and defined what they were, circumference and diameter, and I even told you what variables I'm going to use. So when I wrote this statement, you could read it, circumference proportional to the diameter. As you read along here, and feel free to pause and read, you'll see that I discuss what the y-intercept means. I discuss what the slope is and what it means. I don't just state it, we discuss it. And then we build our specific math model. The slope comes right from my graph here, right? Then I talk about general things. And the general things here was pi. And we plug that in and we get our general math model. Afterwards, we do a percent error calculation with my slope and pi, and then we talk about sources of error. Sources of error is 2 points. It's one of the things that people tend to leave off because it's the very last thing on the rubric. So make sure that you get that on there as well. So I hope that you will read the Circle Lab. Right? It's available on the lab help page, and kind of use this as a template. Use this as the idea of how to write up a lab. Okay? And look at how it flows. This is going to take some time to do. You might get a little bit of time in class, but you'll also have time out of class where you're going to have to work with your group and decide who's going to do what and how you're going to get it all put together. But in the end, it should be a nice, pretty lab that explains everything that you've done. So that is writing the physics lab report.